Assalamu alaikum. This is our project, final project slide from group 9, presented by Aditya, Rifqi, and me, Ali Islam, and KHALIEF, FAIZ. Next. This study aims to explore the impact of caffeine consumption on sleep duration. Despite caffeine's well-known stimulant properties, the exact influence on sleep patterns remains unclear. The research investigates the potential association between caffeine intake and nightly rest by analyzing variables such as sleep duration, caffeine consumption, and caffeine, caffeine status among a sample of population. The study also examined the correlation between different levels of caffeine consumption and sleep duration to identify any significant relationships. Next.
The dataset has 15 variables. In the picture that's shown in this PowerPoint, it's only 10. There is 5 more, but we will be reduced to 3. Sleep duration, caffeine consumption, and caffeine status. Using R, data will be filtered for sleep duration and caffeine consumption, adding caffeine status to indicate if caffeine consumption is greater than 0. Rows with NA values will be removed. The study aims to determine if caffeine affects sleep time. We will be examining the correlation between caffeine consumption and sleep duration. Result will show if and how caffeine impacts sleep time. Next, here are the 3 datasets. The first is sleep duration, records of the total amounts of time each subject slept in hours per day. 2, caffeine consumption, the record of the total amount of caffeine in milligram consumed by subject 24 hours prior to bedtime. 3, caffeine status, a variable to store whether the subject consumed caffeine 24 hours prior to bedtime or not. Next.
Okay, so now we go to data analysis. In the first test, we are going to test the claim that are common in the community, in the humanity, that caffeine will affect the sleep duration of people. So we will assume unequal variance on this test because it is generally safer in producing a conclusion, and we'll use 0.05 significance level. We will use sleep duration and caffeine status as their variables. So here you can see the new one. The mean one is people who consume caffeine 24 hours prior to sleep, and mu 2 is the people who don't. Here we see the hypothesis, our null hypothesis, with no significance difference, of course, and our alternative hypothesis that the sleep duration for caffeine consumer is less. That means the people who drink caffeine will sleep less than people who do. And in the result, we see that these data and the conclusion fail to reject null hypothesis, means that there is no effect. There is no significant difference. It means sleep duration between the people who consume caffeine and not. And after that, we do the correlation test. With null hypothesis, there is no linear correlation between sleep, and in the alternative, there is linear correlation between sleep. And as we see here in the graph, that it's a straight horizontal line, means there is, we see in R is minus 0.014, which is very, very near to 0, which means there is almost no correlation between sleep duration and caffeine consumption. And we see the conclusion here, because the correlation coefficient is minus 0.01, there's little to no correlation between sleep duration and caffeine consumption. And we'll do regression tests to see if is there a linear relationship between sleep duration and caffeine consumption. In this regression test, we want to see how the caffeine will affect people's sleep time. So here we see in the equation, the sleep duration. The equation of the sleep duration is this 7.48 minus 0.0004, means every 1 milligram will decrease minus 0.0004 hours of bedtime, which is nearly nothing, right? So we can conclude that there is no significant relationship between caffeine consumption and sleep duration. Last but not least, we do ANOVA test. In this test, we will change the caffeine consumption. With 0 is the low level, 1 to 50 is medium level, and more than 50, which is 51 and higher, is high. These variables involved are sleep duration and caffeine level, with caffeine level derived from caffeine consumption. The significance level for the test is 0.05. And this in hypothesis, if it's the null hypothesis, if the means of all levels are equal, and our alternative hypothesis that the mean of one level is different from the rest. And we see it in low level, 7.4, medium 7.5, high 7.2, standard deviation, and the results with the R programming, we can conclude that we fail to reject the null hypothesis, meaning different level of caffeine consumption do not affect the sleep time, sleep duration for people.
For the conclusion, we truly analyzed the relationship between caffeine consumption and sleep duration using rigorous data analysis techniques. Our focus on sleep duration, caffeine consumption, and caffeine status aim to cover any significant correlation. Through this hypothesis testing, correlation test, and regression analysis and ANOVA, we found no substantial effect on caffeine on sleep duration. This finding suggests that individual variation or other factor may play a more significant role in sleep patterns. Next. Thank you for listening this presentation. For our closure, we will share our experience while studying probability analytical data analysis.
So first, taking this probability and statistical data analysis course was challenging at first. But actually, the first one is easy. But then go to the middle, it's become challenging. I become a little overwhelmed. But as I study more, I finally understand what it is, and it is actually very simple. And this course has improved my analytical skills and showed me the power of data. What began as a tough challenge has turned into an enjoyable and fulfilling academic experience. Thank you.
For my experience in learning probability and statistical data analysis, provide me with essential skill to predict, event, and interpret data. I started with the basics of probability, including theoretical, experimental, and subjective probabilities. Completing this course, I have gained a comprehensive understanding of probability and statistical data analysis. Now I'm equipped with the skill to analyze data, make informed decision, and apply statistical method to various fields. Thank you.
So first of all, Doctor, my name is FAIZ SYUHADA. I'm very sorry that I am usually late to class and I have a bad midterm test. I want to say sorry and thank you that because in this probability and statistic data analysis, I've learned a lot. I've been using some formula to enhance my company that I've been working for the last semester that previously I only calculated in my head, but now that I have the formula, it's easier and the data is more precise. That's all. Thank you.
Assalamu alaikum. My name is Ali Islam. Starting with the PSDA course, probability and statistical data analysis. We started with random data and see how we can just group it together in different ways and just organize it in different ways. I didn't see much of it. Just thought, okay, that's easy. That's just organizing numbers. Later in this course, we studied how we can use these data and these numbers for advantages, for like for like predicting what will most likely happen, or for understanding in a company, like you can understand what's causing you the most problems, or what's costing you the most money. Like, understanding that you can use probability and statistics for so many things that can help you. The, also realizing that everyone or every business has to use statistics for it to succeed in the long run. That's it. Thank you.
Okay, it seems all, and I want to add one more thing. Thank you, Doctor, for these past 6 months. It has been such a pleasure to study with you, and actually, I really like the way you teach. You assign many assignments, which really train us to do the final exam, the midterm exam. And I hope we see you in the next semester. Thank you, Doctor. Assalamualaikum warahmatullahi wabarakatuh.